Let's learn about mutually exclusive events. Two events are mutually exclusive if they cannot happen at the same time. Like, for example, if you're drawing from a pack of cards, maybe 52 cards, drawing an ace and drawing a king, they are mutually exclusive. Okay, so in the case of mutually exclusive events, if there are two events A and B, so I can say that P of A or B, the probability of event A or B happening is equal to probability of A plus probability of B. This is called the addition law of mutually exclusive events. Addition law of mutually exclusive events. Okay, and when the events are not mutually exclusive, which means they can happen together, in that case the formula is the P of A or B is equal to P of A plus P of B minus the probability of these two events happening together, so P of A and B. Okay, so in notations of like sets, what you can do is P of A or B is written as P of A union B is equal to P of A plus P of B minus P of A intersection B. Okay, so these are the two formulas which you need to remember. One is P of A or B is equal to P of A plus P of B for mutually exclusive events, and for not mutually exclusive, the formula holds this structure. Okay, now when you are talking about in case of Venn diagrams, so for mutually exclusive, the Venn diagrams will look like this. So if this is the whole set, this is event A and this is event B for mutually exclusive, and for non-mutually exclusive, there will be an overlap because they can both happen together. So this portion out of this one, when if you want to study together, this section is P of A intersection B. Okay, and this one is A. The set A is this one. So if they ask for P of A, you need to select this, and similarly it will go for P of B, and out of that you can find P of A union B or A or B. You can find it with the formula P of A plus P of B minus P of A intersection B. Okay, so this is the case when you work with Venn diagrams and the probability is given. You can find the probability of the other ones using this formula. Okay, now let us work on some questions here. Okay, let's look at this question. A box contains disk number 1 to 16. Okay, so for the first question, an odd number, it will be, how many odd numbers can be there? 8. So it is 8 over 16. And for the second number, an odd number or a multiple of 4. Okay, sorry, this is question number 3. Okay, question number 2 is sorry, the order got changed. The question number 2 is the multiple of 4, which is 4 multiples of 4s are there, so it is like 4 over 16. And for the third one, odd number or a multiple of 4, can they happen together? No, so they are mutually exclusive. They cannot happen together, so they are mutually exclusive. So the probability of that happening is probability of odd number plus the probability of multiple of 4, that is equal to 8 over 16 plus 4 over 16, which is equal to 12 over 16. Okay, now let me bring in another question. So the question is this: number selected at random from integers 1 to 12 inclusive. Find the probability that the number is even. So even number probability is 6 over 12. Okay, and the multiple of 3. How many multiples of 3s are there? There will be 4 multiples of 3, right? 3, 6, 9 and 12. So it is 3 multiples of 3. And then the third one, even or a multiple of 3. So as soon as you see or, you have to think whether it is a mutually exclusive event or not mutually exclusive event. So whenever you think about this one, even or a multiple of 3, they can happen together. Yeah. So the even numbers are 2, 4, 6, 8, 10 and 12. So here if you see that there are repeating ones, so which means they're mutually exclusive. So in this case, the formula what you will use is like P of A or B. So A or B is equal to P of A plus P of B minus P of A and B. So in this case it is 6 over 12 plus 4 over 12. And what is P of A intersection B? There are 2 occurrences, so it is like 2 over 12. Then if you simplify this, you will get 8 over 12, which is equal to 2 over 3. Okay. Now let's take another question. Okay, so this question, so pause the video and listen to this lecture. So now find the probability of the car selected is a green estate car. So in this question they haven't given the total number, so our first thing is to find the total. So the total is 100 here, total is 100, the gross total is 200. So there are 200 cars here. Now we are going to find the probability of the car selected as a green estate car. So the green estate car is this one, so it is 32 over 200. Now going for the second one, it's a saloon car. So saloon car, the total is 100, so the probability is 100 over 200. And the third question is a black car or an estate car. So remember or, then you have to see whether it is mutually exclusive or not mutually exclusive. Since we can have it is since there is a black estate car, this is not mutually exclusive. So the formula what you will use is P of A or B is equal to P of A plus P of B minus P of A intersection B. So that is equal to 32 over 200 plus 100 over 200 minus P of A intersection B. A intersection B means black car and an estate car. So what is the probability of black car and an estate car? It is 6. So it is 6 over 200. Then you can simplify this and you will get 106 over 200, or you can further simplify it as 553 over 100. Okay, so this is how whenever you see an or in the question, you have to check whether it is a mutually exclusive event or a not mutually exclusive event. Okay, let's try another question, one more question. Okay, so here there are 40, let's try to understand it. Okay, so 40 red, 30 blue and 30 green. Okay, if the winning ticket was drawn at random, find the probability or that it was red. So for the first question, the probability if it was red is 40 over 100. And not blue means you have to calculate the red and green, which will be 70 over 100. Okay, now if every red ticket is even numbered, so every red ticket is even numbered, every blue ticket is odd numbered. Of the green tickets, 20 are even numbered and 20 are even and 10 are odd number. Okay, so I'm just trying to picturize it so that it becomes very easy. Now what you have to do is find the green or even numbered. So again, there is an or here, so remember whether it is mutually exclusive or not mutually exclusive. Green even number card exists, so it is not mutually exclusive. So what you have to do is like the formula. So the probability of the first one, so probability of green plus probability of even numbered minus probability of green and even. Okay, so now in this case we have, this is probability of green, no, this is not green, this is red. So probability of green is 30 over 100, and probability of even is you have to find the total number of even cards. So it is 40 plus 20, which is 60 over 100, minus probability of green and even, which is again this one. So it is 20 over 100. So that is equal to 70 over 100, which is equal to 7 over 10.